Hi team, this is Gautam here. Welcome to my project, my capstone project for this Gen AI intensive course. My topic here is Smart Auto Assist. So here is my blog that I have written in the Medium. Coming to the problem statements, have you ever wondered when you're driving a new car or any new rental car, a strange symbol popping up on the dashboard and you have no clue what it is? Or if you go to any insurance site or a Carfax or any dealer, you are in need of a VIN number. How many of you know where you can find the VIN number on your car? Or sometimes, if you want to fill air in your tires, do you know, how much PSI or the pressure that you need to fill in the front or the rear wheels, where you can find this information? So all this information is available in a car manual, which is like at least 200 to 400 pages. How many of you really go through the manual when you buy a car, or when you get a new car? We often don't do that. Like 90% of us don't do that. So I want to address all these issues here. So with single solution, it's called Smart Auto Assist. So Smart Auto Assist is a one-stop solution for all these problems. It is powered by AI agent. So during development of this app or application Smart Auto Assist, I have leveraged these Gen AI features, the image understanding, the RAG. So when I'm developing the RAG, I have used the Chroma DB, which is a vector store, and then embeddings, and I've created an agent and a function calling and then grounding with Google search. So I have leveraged all these features from the Gen AI and implemented this project. Coming to the workflow, like how this project works is, suppose like you have seen here, I have a car and I have an agent. It has two main functionalities. One, the image analysis, the image upload. Second thing is a chatbot. For example, you're driving a car and you have seen a strange symbol coming up on the dashboard. So as a user, I just take a picture of my dashboard and then upload into this app. And this application, as soon as the agency's a new image is received, it will pass that image to the image analysis component, which will extract all the information from the image. So when the image contents sees low fuel, automatically my agent will call a Google search and give the nearest gas stations. And suppose if the image contains any warning symbol, particular to warning symbols, so my agent is gonna pass the warning symbols to a Google search and then list on what is the severity of those warnings. Like, and if it is a high severity, then I will do a Google search for the nearest service stations. So like if it is a low fuel, I will be doing a Google search for the nearest gas stations. If there is any warning symbol, which is of high severity, any of the severity, it will look for the nearest service centers. A small assumption that I have made here is, as it needs, when I say the nearest, that is my ultimate aim. But as far as this project is concerned, since we are running a notebook, I'm not sure from which location we'll be running a notebook. So instead of taking the GPS location, which is not possible in this scenario, I have assumed that it is in New York City. So I'll be showing nearest gas stations around New York City and the service centers around New York City. That is my first assumption that I have made. And coming to the second functionality, for example, like I mentioned before, I want to know where I can find the VIN number. So I do a chat. I ask a question to this agent, hey, where can I find the VIN number? So my agent will take that question and then it will pass on to the rack. So what I have done here is I have taken for example, I have taken the BMW X3 model car manual, and I have prepared a RAG out of that PDF file, which is like a 400-page document. I'll go through the code in a minute how I implemented that. So when I give a question where to find the VIN number, my agent will try to get answer from the RAG, or In other words, it will try to get an answer from a car manual. If it finds the answer, well and good, it's going to return the answer from the car manual. If it don't find that answer, then it's going to pass that query to the Google search and then get the answers from that. I'll be giving an example, like, on both the cases during my testing at the end of this project. So having said this clear workflow, so what I have described, explained you so far, I have written it clearly in my blog, right? So this is the car manual that so this is a car manual uh, that I've used to develop my RAG, so which is a owner's manual of a BMW X3 model, like, which is close to 390 or 400-ish pages. It's close to 408 pages. Yeah. Now, to start with the notebook, yeah, I have installed, so starting with installation libraries, I have installed all the required libraries, which is needed to leverage those 7 or 8 Gen A capabilities. I have installed the LangChain, LangGraph, like all the libraries which is needed for the grounding, agent, image processing, and then the RAG, right? And then, of course, we need the Google API key. I got the Google API key and from the Google API Store. And I will start with the image analysis part. So yeah, so once I downloaded all the libraries here, I have imported the request pill and then the GenA. So starting from the request, so for the since we are running this in the notebook, I'll be giving the endpoint. I'll be giving the URL of my image where the image is located. In this case, it is located in the in a GitHub repository. So where I'll be passing on this URL. I'll be passing on this URL, right? So I'll like you can pass any HTTP URL. So I'll be loading the image from the HTTP URL, and then I'll be processing the image. So to extract content from the image, I have given a prompt like, describe the contents of the image, and if the image contains warning lights, indicate the severity of the warning in bold. So I'm gonna list down the severity of these warnings as well in the bold. That will be my output of my image that is extracted from a HTTP URL, right? And coming to the second side, to do the chat mechanism, I need to start building the RAG. So again, the same case, I'll be passing my manual in the form of a PDF from my GitHub, from my GitHub location. So this is my GitHub location where I have this manual, right? So, and I'll be passing the raw URL of this manual. So to begin with, like, so this is my string variable which contains the URL of my manual, and then using the request, I'll be calling this endpoint, and I'm sorry, I'll be passing this I'll be calling this HTTP URL and downloading that PDF file into a temporary variable we call it as downloaded PDF path. And of course, since it is a HTTP call, there are chances that some exceptions might occur depending on multiple reasons like the network thing or the Git outage or anything. So I have to raise the proper exceptions. So the exception handling is also done as part of this. And suppose if the file itself is not found, then I have to throw a proper error to the user. So in this case, it has attempted to download the PDF, and the PDF was successfully downloaded and it has saved to the temporary file. Now, once I got the PDF, I have to split the PDF into small chunks. So before doing that, I need a text splitter to to break down my PDF, right? So I have used a recursive character text splitter, which will split the entire text of my PDF into smaller chunks, right? So So here I have loaded my PDF into temporary download a temporary file. Now from this I am using the PyPDF loader. I'm loading the PDF, and I'm getting the pages of the PDF. So once I get the pages of a PDF, I'm using the recursive character text splitter, and I like I said, I'm chunking those PDF into small chunks of 1,000 characters each, and sometimes the chunk or like overlap can happen, which I'm giving as 100 characters of a overlap, and I am getting the corresponding text splitter. And using the text splitter, I'll be splitting those pages, the PDF pages, into individual chunks. So out of the 408 pages which we saw from the PDF, with each chunk size of 1,000 characters, finally I got 1036 chunks. Now, once we get those chunks, I need to do the embeddings, right? Now, to do these embeddings, I have used uh, model slash embeddings 001. So this is my embedding model that I've used, and Gemini Flash is the model that I've used for developing the RAG. Yeah, so using the Google generative AI embedding and the embedding model which I said, I have created these embeddings with the task retrieval document and passing the Google API key. Now I have my chunks ready. I have my embedding models ready. Next, when I do the semantic search, I need to store like to do the semantic search, I need a vector. I need a vector store. So here in this case, I'm using ChromaDB as my vector store to store all my vectors, right? So now using the ChromaDB, I have imported from this LangChain community vector stores, right? Using the Chroma from the documents function, I'm passing those chunks and I'm passing those embeddings. And using this, I am creating a local vector store which will store all my vectors. So to convert that 1036 chunks, I have created 1036 vectors in the store. It's like a one-to-one mapping, right? Now I have finally I have the vector store. Now uh, now to develop my RAG, I need my LLM model, right? So I using the like I said, it is a chatbot. So using the chat Google generative AI library, I'm passing the model. I'm setting the temperature to 0.3 and creating my LLM model for this. Now I have my LLM model and I have my vector store. Now using this vector store, using this vector store, I have created a retriever and then combining all this information, I have created my RAG. So my RAG, I am passing my retriever, and then I'm passing my LLM model, right? Now, how do I extract? I need some kind of a prompt, right, to get information from my RAG. So this is a predefined prompt. I'm telling based on the context provided, so which is nothing but a car PDF manual in the form of vectors, answer the question. And if the context doesn't have any answer, state that you cannot answer based on the provided information. So we need these lines specifically so that if my agent, whenever it sees this answer, that the based on the context which is provided, it cannot answer this information immediately, it will go and do a Google search. So I'm explicitly mentioning my RAG to give a response saying, if it doesn't contain any information, it has to return, that it cannot answer that particular question. So finally, I have created my RAG successfully, and then yeah, now I have my RAG. Now I need some kind of a function where it can accept a query and then invoke this RAG. So here I have created a car manual RAG function which will accept a query in the form of a string. So you pass a string, and it will in and then it will invoke the RAG, and then I'm going to print the answer, and then it's going to return me the answer, which will be taken by the agent and then take a decision based on what to do next. Right. So far, I have explained the image analysis part, and then the chatbot part, and then the RAG part. So like I said in the workflow, I have covered my image analysis is done, chatbot is done. Now, final thing is the Google search, for which I need to implement the grounding. Right. Now, to do the grounding, I have used a library called search. This one, the generative content config, and use it from the types, I get this Google search. So yeah, so basically, I'm using this tool Google search with the types of generate types of Google search function, which will give me the configuration with the search. Now, whenever I pass a query to the grounding with Google, uh, running with the Google, I'm going to use this model Gemini 2.0 Flash, and then I'll be passing this query, and then I'll be passing this config, which is nothing but a tool for my Google search, to my client. So now, whenever I get a query, it will do a Google search, and then it gonna give me a response. Now, this response can be of a different formats. So if it is a text, I'm going to return the text. If it is in data, I'm going to return the data. If it is a JSON, yeah, I'm going to return the JSON. Yes. So now I have in my workflow, I have developed individual components: the grounding with Google search, image analysis, and also the chat. Now, I have to create a central agent which can interact with all these individual components. Now, to develop the agent, I have taken the help of a line graph. So I have developed my agent in the line graph with the different nodes. Starting off with, I have defined an agent state, which will always contain the current information of my agent and also the current information that is held in the state. And then this is the fallback mechanism which I have clearly said before. So this is one of the key function for my RAG, where if it sees any of these phrases, like cannot answer based on the provided information, like I don't have any information, like insufficient in information provided, or like I don't know, if it is any of these phrases that is returned from the RAG, then it will return true, it will return true, and then it will return false. So should you use the Google search based on these phrases? If the answer contains any of these phrases, it will return true, which means should you use the search? Yes. If we don't have the information, it will return true, and then it will go and call the Google search. If not, it will return false, which phone to the Google search. And then I have to define a set of tools which is needed for my agent uh, to finally build this app, right? So like I mentioned before, so one tool is the car manual, one tool is the Google search, and one tool is the image analysis. So these three are the main key tools that is the core function of this application. Now, once I have my tools, once I have my function, a backup function, like the callback function, now I have to start defining the nodes of my line graph. So one node is the processing the query, and then one node will be load by the answer based on the quality, whether it should should you use the search. So based on the answer from a RAG, it will use the RAG or it will use the Google search. And then if it uses the RAG, then it will go and search for the final answer from the RAG and the source, and it will give the response, where I'm also indicating from where the answer is coming from, what is the source of this answer, whether it is from the car manual or from the Google search, right? And finally, the processing the image. So like I mentioned here, So I get the image. So I pass a question with the image URL, and then getting the contents. So once I get the content, it will be looking for the fuel. Like if the image contains has the keyword called low fuel, it will be searching the nearest gas stations in the New York City. Like I said before, I'm assuming like this is one as assumption, like to get the nearest possible gas stations or the service stations. I'm assuming that currently I'm in the New York City, so I'll be showing the nearest gas stations or the nearest service stations depending on the low fuel or the warning lights. Finally, I now have these functions, the nodes, and then the callback mechanism. Now using the line graph, I am wiring all these small components into a single place. So I am creating a workflow. So in the workflow, I am adding the nodes. So these are my nodes where it will process the question, it will process the image, it will try to answer from the RAG, or it will try to do a Google search, and also my routing mechanism, right, based on the quality of my answer, right? And what are my entry points is the processing the question, and what are my end nodes is the processing the image or a RAG or a search. Finally I'm compiling my workflow, and here is the function calling. So this is my final function call called as a run car assistance, which will take the question, and whether if it is the image or a chat, depending on the true or false, it will route the question accordingly. Yeah. So these are the small testing functions which I created individually. Smart auto assist, and then followed by the image, and then I'll be passing the image URL. If I want to invoke the smart auto assist a chat, I'll be passing the query. I also added a small snippet code for the interactive mode, which I'll not be running, as there is a condition, like where the my notebook LLM should pass, like should be able to run. So the interactive mode will not work in this scenario. Coming to the testing part, like I said, so here I have added a small two functions for the image and the chat, so which will actually run the car assistance function here, right? Now, my first use case, I have got like like all the way, like I mentioned before, I want to see where the win is located in the car from the car manual. So I'll pass this question: where is the win is located in the smart auto assist? Now the car assistants will be invoked. Now the answer which I got from the car manual is the win is located on the engine component on the right hand side of the vehicle. So this is from my PDF manual. Like I mentioned before, once I printed my answer, I'm also telling what is the source of this information, from where it is coming. So the answer is coming from the car manual. And my second use case, suppose if the RAG has no answer, it should be able to do the Google search. So what is the difference between all-wheel drive and the forward-wheel drive? So the answer which I got is like, no, I cannot answer based on the provided information. The text mentions all-wheel drive, and it is benefited for the improved drive, for the improved drive power, but it doesn't explain the complete difference. So the RAG was, or the model is smart enough, it will try to get some content around the all-wheel drive, because the manual which I've chosen is for the BMW X3. It is a all-wheel drive model, so it was able to pick up that answer. It is smart enough to pick up that particular all-wheel drive answer, but it is not sufficient information to answer this. So it says like, it cannot answer my question. And then as a fallback mechanism, it goes to the Google search, and then it will try to differentiate between the forward wheel drive and then the all-wheel drive. What are the benefits, pros and cons of it? And here you can see the source of this information is the grounding with Google search. And finally, my favorite, the third use case scenario, the image analysis. Like, for example, I'm driving, so this is a sample. image that if I encounter this, like, I see multiple things started popping up on my screen. I don't know what to do. So I take an image of this, and I'm gonna submit to my smart auto assist image, right? So it will do the image analysis. It will process the image. It will start loading this image. And here are my image contents. So on the left page, what is like, it's showing the engine RPM, and on the right page, it is showing the speedometer, which yeah, which is good to know. But here I'm more concerned on certain things, like I said before, a low fuel warning. So as soon as it sees the low fuel warning, it will show me the general gas options, listed in the New York City. Like, these are the gas stations which are which are available in the New York City. And this image also has warning symbols. So here I am highlighting these warning symbols. So for example, you see the engine oil, the battery, the car seat belt, and I really don't know what this means. Let's see what it is. Let's check the tire pressure, the battery warning, oil pressure, tire pressure warning. Yeah. Uh, yeah. So it has all. It has clearly mentioned 1, 2, 3, 4. Yeah. Seatbelt warning. Oh, this is a check engine light. Yeah, so that is nothing but a check engine light. Yeah. So, but that is a medium severity. Uh, but it has some of the high severity, such as, like, the battery light warning, and then the oil pressure warning, which was like a high severity. So it will suggest me the nearest service stations. So it will suggest me these are the nearest service stations, car in the New York City, like, around this. Yeah, that's all. So hopefully I have tried to explain myself clearly with all the examples and then the code. Please feel free to go through my blog and then answer me your inputs. Thank you all.